I think we have had a good 10-minute break. So this talk is going to be about intro to AI. Uh, just to set the expectations right, I am not a AI expert. The way this talk ended up happening is so I'm one of the organizers for the CNCF community along with Atul. I was part of the original team back in 2018-19 when we started the community as well. Um, but we actually planned to have another speaker, and they had confirmed as well. They were a data scientist, I think, from Oracle, but last minute they couldn't get the approval to speak. So they backed out, and we looked for another speaker. We got the confirmation. That person was a founder of an AI startup from Hyderabad. We were looking forward for that talk, but just 2 days ago, he also backed out. So last minute, we decided, okay, let's put this together. So my background, I'll give a quick intro about myself as well, but that's the expectation. This is going to be a very high level. I'm sure there'll be people here in the audience and other speakers who already have a lot of understanding about the entire domain of AI, what's happening. And I'm open to other people kind of chiming in and giving their inputs as well as we go along. But just for others who are still trying to understand what is going on, right? Because for the last year and a half, there's been such a massive hype and so much conversation, so much momentum around this domain. All the entire industry has been pivoting and moving towards this. So what is going on? What is all of this? Just understanding it from a high level. So introduction to the landscape of AI. What are the latest trends happening? What are some open source projects and tools you can become familiar with? And how do you get started yourself from a personal point of view, right? Um, so I'll talk about me, give an introduction about me, what I do, my work, things I'm involved with first. Then a quick rundown of AI as well, the landscape of AI. Then the open source landscape and a bit focused on CNCF ecosystem as well. And then how can you get started? That's the idea. We'll keep it quick in that manner. So about me, I work as a lead solution architect today at Minfi Technologies. And at Minfi, I solve architecture problems for small startups as well as large enterprises. I'll talk a little bit more about Minfi, but other than that, I'm also a founder of an organization myself, Codaplex Technologies, which I had started many years ago. So before all of this, I used to run communities full time. There might be a few of you who might remember me from many years ago. I used to run back in 2016, I started the Free Code Camp Hyderabad community, and then it turned into Coderplex community. We used to organize a meetup every single weekend. There were weekends when I organized 2 or 3 meetups at the same time, same day as well. So there were a lot of meetups. I've organized like 1,000, 2,000 plus meetups over a few years, basically. And I was doing that full time as a non-profit, activity basically. We tried running a hacker school, boot camp, a lot of different programs to help people learn because students they were struggling to learn in college, and people at different workplaces were struggling to learn and keep up with modern technologies as well. So we wanted to build an ecosystem for that. That's when I became very passionate and involved in that. I was running that, and that is when I started building Codaplex Technologies as well. So around that time, I was so precursor to that, I'm a self-taught developer myself. I didn't go to college actually. So I never went to college, never applied, completely self-taught. And I wanted to help other people learn through online technologies as well. Right. So there is a story there. I don't want to distract the conversation, but that's the background. So the reason why I started the community and this whole thing was I wanted to help other people learn. Give them direction, guidance, support, mentorship, whatever necessary. So in the middle with Codaplex Technologies, so we even today it does exist. Okay, I'll talk about it in the next slide, but about a bit more about me. I like reading books. I like learning things, playing basketball, solving problems, building stuff. Right, that's about me. So again, let me just finish. What do I do? What does Minfi do? Quickly. Minfi is a premier AWS partner company based out of Hyderabad. It's a global company at this point. We have operations in US, Australia, Europe, everywhere, Singapore, everywhere. And we work on migration, modernization, application development, DevOps, AI, ML use cases, managed services, everything. So we work with startups, we work with large enterprises, we work across the entire spectrum, and we work hand in hand with AWS. In India, we are one of the leading partner companies, basically. So we have worked with some very large enterprises doing some amazing work with like massive migrations to AWS, modernizations as well with healthcare companies, payment infra companies, etc. as well. I've been directly involved as the lead solution architect for these engagements, and I've also been involved. So Minfi for the past year and a half has been the aerospace partner company as well. So there's been a lot of boom of startups in aerospace domain since the success of SpaceX. So a lot of these startups are trying to figure out how do we leverage cloud. So we came in as the partner company working with these aerospace startups and doing that. And I worked hand in hand with a lot of these aerospace startups. That's about Minfi. You can check out the website minfitech.com. Coderplex. So this website we just actually launched recently. I was building a edtech platform as well for people to like learn. So we strongly believed in open source learning, free learning, all of that. So we were building a platform where people can go through online resources, learn by themselves, all of that. Right now, if you go to coderplex.dev, this is a very simple platform we built recently. Just think of it like LinkedIn, but for developers. That's what we are trying to do, like a professional network for developers. So there's not much on it right now, but we are just trying to, all the community members we have had in the community, we have a very active WhatsApp group, etc., trying to just bring them here. So the idea is build this kind of a platform, help the developers learn, level up, and also help them get remote jobs. That's a secondary thing, but that's something we are doing with Coderplex. That's the story of Coderplex, all of that. Now, I think we can move more towards the actual talk. So again, we did this in such a rush. I actually started preparing this just today morning. It's very fresh still. So one thing I wanted to do was let's get a quick history of AI. Right, there's been such a long journey with the domain of AI over so many decades, and everything has sped up in the last few years. But understanding the history would be helpful. But how do I get a quick summary? We have LLMs to summarize quickly for us. So this is Poe. And if some of you are not aware, there is OpenAI, all these different platforms. A lot of people are confused. Which platform do I use? I personally use Poe. So Poe is a platform by the founders of Quora, where you can get access to pretty much all the models at once, basically. So you can get access to OpenAI, Claude, or Mistral, or DeepSeek, or any of the models. So this is just OpenAI. I just asked the summary of AI here. So it's like it starts in 1950s, birth of AI, key innovations is symbolic AI, logic-based systems. So Alan Turing's Turing test is one of the first stages of the concept of AI comes in the creation of this perceptron, which was the very early stage neural network, very rudimentary early stage stuff. Then there is an AI winter where not much is happening. There's a lot of researchers who are trying to work on it, figuring it out, and innovate on it. But it's kind of slow. They're kind of limited by the compute, right? There's just not as much powerful computation available at the time, right? But they're still trying to make it work with the constraints they have. So then we have the 1990s. There's a lot of growth that happens. One of the biggest milestones was the Deep Blue by IBM, which defeats Garry Kasparov in chess. That was a big milestone where a human was defeated by a AI system, right? In a game that was so popular across the world. Then there are a few other AI innovations that have happened in that decade. Then we come into the 2000 era, and there's Geoffrey Hinton's reintroduces deep learning as well, and then there's Google self-driving project. There's a lot of innovations happening at these large companies, right? So Google is growing really fast. They have millions and millions of users, so much data, and they start investing in AI systems. And there's I think acquisition of DeepMind happens as well. So there's a lot of research activity that's going on at the time. Then we entered the 2010s. There's a lot more progress with computer vision, with NLP, with reinforcement learning. There's generative adversarial networks. Then there's AlphaGo by DeepMind in 2016, which was a major milestone, if you people remember. This was similar to Deep Blue. This was the milestone where the game Go, the AI was able to accomplish finally being able to beat a human being at the game Go, which is 1,000 times more complicated than chess as a game. So that was a major milestone as well. Release of BERT, this is Google's model for, like so Google releases the attention is all you need paper, basically, Google with few other researchers, and that introduces the concept of transformers. And they work on this BERT as their solution for transformers, basically. So then a lot of things accelerate. OpenAI comes in, is established, and that is when they they start working on GPT, right? And GPT is their implementation of the transformer, basically. There's the GPT-1, the GPT-2. Not many people were paying as much attention at the time because it was all happening indoors, and they were releasing the model and having their research papers published. But it was still not that familiar to the wider public. It was GPT-3 that completely, it was a tsunami. It was a big change in the entire ecosystem. GPT-3 came in, and then the board of OpenAI realized that it's very good. We can't give access to people easily to this. So let's put an API and limit the controls of, who gets access to this. That's when the proper API setup was done for GPT-3. And then on top of that, there was ChatGPT launched, right? So that's when everything changed, right? So first version of ChatGPT, just GPT-3 and 3.5. And then just a few months later, they launch GPT-4. Around the same time, there's a lot of innovation happening with computer vision, image generation, video generation as well. So they launched DALI, which is a image generation AI, and then there is other teams, other projects that come out as well. Stable Diffusion comes out, Mid Journey comes out, and these become very popular. This kicks off the big chase of, it's almost like a gold rush at this point. Like, this is amazing amount of power. What can we do with this? Everyone is trying to figure it out and integrate it, right? Now we have the current trends of autonomous systems, figuring out the future of AI, the AGI, rush, trying to get to AI that can be equivalent or even better in terms of cognitive tasks, etc., than a human being might be, right? So that's where all of this comes. Then there's a lot of conversation about how this applies in enterprises, in cloud, and across the entire ecosystem, and the concepts of the philosophy and ethics of AI as well, right? There's a big discussion around that as well. So that's the current state we are in. This is a quick history. And now we'll look at a little bit of the landscape, what's actually happening, who are the players, what's going on, right? So who are the main players in the game? There's OpenAI, there's Anthropic, which is behind the Claude model. There is Google with DeepMind. DeepMind was acquired by Google. Google had multiple divisions of AI, which so when OpenAI launched, they had to scramble into trying to put everything together because they were not planning to productize in the same way. But OpenAI changed the entire story for them as well. So Google then tried to pull all the teams together into a single body of AI, applied AI, and building the solutions and products and launching them for public as well. Then Meta came in. Meta had a whole different story. They had a lot of GPUs that they had acquired ahead of time for the Instagram, essentially, to run the models for like recommendation engine on Instagram, like for reels, etc., basically. But then this whole revolution happens, and they're like, we have so much compute available, now we can really utilize this, and they start accelerating their AI research and work as well, and they decide to go against the tide of private models, which is what Google and etc. were doing, and then they launched Llama, right? So Llama was the first proper big open source model that comes out, which was quite powerful. Then some French startup comes out, Mistral, which no one was expecting, and it comes out with an open source model as well, and they don't do any PR, don't do anything. They have an amazing model available for public, and they just launch it without any additional marketing words, nothing else. Just silently just announce a research paper and the model, and that's it. And it takes the world by storm. Like, what is this? Who are these people? And how did they do this? Right? So that was a big movement. And now the latest one is DeepSeek. All of you have been seeing the news. This comes out of China. Everyone is completely amazed with what has happened here because they have not had the same computational power as all these other companies. They have had significantly less computational power. In fact, the US government had sanctioned China that NVIDIA was not allowed to export their hardware, the GPUs, to China. The same hardware, the H100s, they were not allowed to export them out to China. So US didn't want China to have the same leverage or technological advantage as they had. But there's a company in China which was doing high frequency trading basically, right? So this is using computers to do trading basically, right? So they would have a lot of computers set up and algorithms and everything set up to just do a lot of high frequency trading with millions and billions of dollars. So they had a lot of compute already available for that purpose for doing high frequency trading. But then when this movement of AI started happening, they realized they can repurpose this for the need of building a foundational LLM model as well. And they had much comparatively, they still had less. And they if you and Nvidia was exporting more, hardware that was slightly reduced in capacity and power as well, right? So H800s I think is what they were selling in China. So even so, with the limited budget, limited compute and everything, they were able to completely rethink how to build a foundational model. And they came out with DeepSeek 1 and then recently the newer model, which seems to be able to compete with, OpenAI, Anthropic, all of them. And just the investment difference between them is so huge that it's completely shocking. Then you have all these acronyms basically: LLMs, GPT, RL, HF, AGI, MLOps, RAG, etc. So we'll talk about all of this in the next slide. There's terminologies that people are using like transformers, fine tuning, embedding, tokens, weights, inference, and more. Right? What is all this? Right? There's so much jargon. How do you understand this? How do you make sense of it? And how do you converse about this? To be involved in what's happening. Then there's a lot of Gen AI code gen stuff which you can use individually, right? So how many of you have used Cursor already? Nice. So at least 30-40% of people. So I'll show you a little bit of Cursor in a second as well. There is continue.dev as an alternative to Cursor as well. There's Windsurf. These are for coding purposes. Then there's GitHub Copilot as well. So there was efforts put in. There's a lot of open source software out there, and so much of it is on GitHub, right? And you can set up training a model by pulling all of the open source code base, training the model on all of that, and then it's able to generate code, like training it to be able to generate code based on that, training with the open source code base. So that kind of changed the story of how you can do software development today as well, right? That has impacted how developers can function, how quickly they can do things as well. So that's another story. And then there's smaller tools like v0.dev, which has become incredibly good at generating front end, right? So if you want to build front end applications, v0.dev is one of the leading solutions for prompting and generating a complete front end within minutes, basically, and going live. Then there's of course the CNCF landscape, more specifically about Kubernetes and the entire ecosystem and what tools open source projects are available to be able to build the infra for this, right? Like if you want to build the AI solutions for enterprises, for your own companies, etc., right? For customers, etc. We'll go through that a bit as well. Then there are, this whole new story of, AI agents, right? So how do you build AI agents? What are the tools, frameworks available to build that? What is it? All of that, right? So that's the landscape. So acronyms and terminology. Let's quickly go through that and understand it at a high enough level. You can read more about all of this. Of course, we'll share a few resources with you. NLP is natural language processing, right? So it's just this computational system being able to understand natural language, training it on human text, on natural language, so that it's able to understand, predict, make sense of human text, right? Then there is large language models. LLMs is large language models. The keyword here is large, right? So language models are essentially what NLPs are, right? You can have a small language model or you can have a large language model. Large language model is nothing but training the model on a very large amount of text, which is in today's sense is all of the text available on the internet, right? So just scrape everything on the entire internet, whatever you can find, and train the model on it. Now it's able to basically as a very simple analogy, all of you on WhatsApp, when you type, you have seen the prediction, right? Like it's predicting the next word for you. That's a very, very, very small language model, very, very, very small. But this is the same thing, scaled up to the entire internet, right? So it's able to, you give a prompt and it's able to predict the next word, next word, next word, or essentially tokens, but it's able to figure out what should be the response to this prompt, right? That's how it's working. It's the way you type a single text and it gives you a small single word as a prediction. It's the same thing scaled up with the large language models. GPT is your generative pre-trained transformer. This is the implementation of the transformer from OpenAI, and its models are named after the GPT basically. Google uses the BERT. RLHF, right? This is something where, in terms of, these companies build these models and then they're like, how do we make this more useful, right? Because it's still not, it's generating a lot of stuff, but it's not as useful. That's where the reinforcement learning from human feedback comes in, where you actually have teams of people, humans, working with the model, which kind of inform the model of what they are expecting, what they think is the right answer, and that helps improve the model itself so that it's more useful to human beings, right? Because it has no sense of what is useful to us, right? It's generating a lot of stuff, but it has no idea what is actually useful, what do we want, what do people want, right? So that this as a framework, as a implementation is helpful in that way. There's AGI, artificial general intelligence, is most talked about buzzword honestly at this point, but the idea is as simple as, can we create a AI that is as competent as, maybe the most intellectual human being or whatever, right? Like cognitively as much or more, right? Competent in terms of, the general intelligence. So specialized intelligence is where it's trained on one specific thing. Like AlphaGo was trained on Go, the game Go, right? Or Deep Blue was trained on chess. So they are specialized in that domain, but you can't ask them to generalize their abilities across other domains. That's where the general intelligence becomes useful, where you train the model to be able to do pattern recognition and help in a very general way, right? Abstract way, right? So that's the general intelligence AGI concept, and the race across all of these companies is to achieve AGI. Once you have AGI, it should be able to do anything. It's like having a human inside a computer available across the world, right? So you can get it to do anything, ask it to do anything, deploy it to do anything, a lot of stuff, right? So it can answer anything. It can function as a teacher, as a mentor, as anything, right? So that's the idea behind it. ML ops, machine learning ops, is just concept of DevOps applied to ML. There's with ML, there's pipeline, right? There's data, training the data, labeling, classifying, all that stuff, and deploying the ML and managing how it's functioning as well, if it's deviating from its function or not, all of that. There's a whole pipeline of ML. And the operations of that is ML ops basically. And you can build this as a solution, as a platform into your infra as well if you're working with machine learning models. RAG is retrieval augmented generation. This is useful because LLMs basically do not know anything about your specific data, like your enterprise data, private data, right? So RAG is useful where you can set it up as a framework for the LLM to have access to information that it has not been trained on, so that it can give more specific answers to your queries, right? So these are the acronyms: neural nets, transformers, fine-tuning, embedding, tokens, weights, inference, agents. Neural nets are nothing but taking the concept of how our brains work with neurons and a network of neurons, right? Each neuron dedicated to some sort of a action, activity sort of a thing. And this is the same thing in a computational sense, right? Where you have nodes and you build a network of nodes, and all of these nodes are able to do some operation, some mathematical logic or something. And you have a network of them so that over a large enough swath of such nodes, you're able to do more intelligent tasks, figure out a lot more intelligent things. If you understand the underlying architecture of it, how it's actually working, it seems quite simple once you get it. Then there's Transformers neural network architecture designed for sequential data, powering modern AI like GPT and BERT. This is what has powered all of the LLM's generative AI stuff that we are familiar with. There's fine tuning, which is taking an LLM and improving it specifically for a certain use case. Embeddings, numeric representation of data in vector form to capture relationships and meaning. With ASCII, we have understood that you can convert anything into digits and numbers, and computers do not understand words, right? Humans do. So you have to convert everything into certain sort of a numeric manner, which turns into binary, whatever that the computer can actually understand. So embeddings and vectors, etc., is that basically taking all information, be it in whatever format, media format, converting into some sort of a numeric code that you can then inject input, feed into the machine, and it's able to train on it and figure out the patterns, etc. Token, smallest units of input data, words or sub-words processed by a model. So it's like synonyms, right? Like every word has synonyms. It's like that, right? So tokens are like small units of words, etc. Weights are parameters in a neural network that determine the importance of inputs during training. So it's just weightages basically, right? So across the training set, there might be certain parameters that have more importance than other parameters. So your weightage defines which parameter the LLM, the model should focus a lot more on, right? So that's what weights are. And inference, using a trained AI model to make predictions or generate inputs. Now you have a model, you want to give it some sort of a task to figure something out, give a response. That's where inference as a concept comes in, right? You have it completely trained on a certain segment of data and then asking it to make certain predictions on some new data. That concept is called inference, basically. Agents is this new thing where you have autonomous AI systems running on the system, whatever, however you set it up, to be able to take certain actions. So AI agent or like AI LLM, whatever, enabled with maybe your terminal or browser so that it can go and actually do things, right? So that's what agents are essentially. The CNCF landscape. This is actually quite elaborate. I'll not go over completely, but I'll strongly recommend you open this white paper and read it. This is a white paper by CNCF originally, and it gives you a very good, comprehensive, elaborate understanding of not just the CNCF ecosystem, but broader AI itself, what's been happening in AI, all of the things I've been talking about. It actually describes all of it. It's a very long article, but do spend time going through it. So there's, for example, cloud native AI can be split between predictive and generative, right? And the type of, so the hardware is generally the same. You have NVIDIA, etc. Cloud platforms could be Azure, AWS, GCP, etc. Then you have Kubernetes or any kind of, like OS level, tools you might be using. Then there's the ML lifecycle, data preparation, model training, model serving, performance scaling, and observability of the ML models as well. And then you can have certain types of algorithms like classification, object detection, clustering, forecasting for predictive AI, and then for generative it can be RAG, LLM, vector DBs, all of that, right? So that's just I would strongly recommend that you go through this entire document. It is very elaborate and descriptive. There's a few like this is the ML lifecycle that we were just talking about, right? Data preparation, feature store, model development, model storage, model serving, and there's tools in the ecosystem, CNCF ecosystem and open source ecosystem that you can use for all of the stages here, basically, right? Starting with how you leverage Kubernetes for your model training, deployment, all of that as well. So in terms of specific, if you there's a lot of information across all of this, but if you look for specific projects that you can utilize, it's right here. So evolving solutions for AI/ML, this section, you will have more specific projects that you can look at. Kubeflow is the major one, where it's essentially a solution for doing your ML operations on Kubernetes, right? So this is a project you can check out. Then there is for vector databases, there's a lot of options. Redis is a go-to one. There's Milvus, FICE, and Waviate, right? These are open source projects you can look at. For observability, there's OpenLLMetry, which is built on top of OpenTelemetry. You can look at this as well for doing the observability of your LLM models and architecture. There's a whole landscape diagram here as well that you can look at. It actually very neatly explains all of the projects in the landscape for AI/ML. You can look at this and go through each of these projects for different use cases: ML serving, general orchestration, CI/CD. There's distributed training, etc. So this is about the landscape. And yeah, so we have only a little bit of time, so I wanted to quickly show something where it's so how do you get started is a question, right? Like there's learning resources, and then there's building something of your own. So I recently actually started trying to figure out how do I use this myself, and I'm a solution architect. So I thought, can I build a agent or chatbot of for solution architecture itself? So I started playing around with it. Me and my friend started working on it. It's a very simple chatbot. It doesn't really do that much. I'll just show it to you quickly. So you can see on the top, we have enabled multiple models here: OpenAI, Anthropic, and DeepSeek. You can use DeepSeek as well. It's nothing magic, right? It's a very simple stuff. It's just using the API. It's a very simple wrapper on the API with a certain constraint of what it's supposed to talk about and not talk about, right? That's all it is, and it should be able to help more with solution architecture questions, requests, prompts, etc. Basically. So I'll quickly just go through this conversation to see what response it gives. There's an option to enable streaming where it will automatically stream the response from the model as well from the API. How many users? 500 users. Is it for technical support, general customer inquiries? I'm not going to give it too elaborate answers. So it's recommending AWS Lex. We'll use this for building the chat bot. Lex provides advanced deep learning functionalities for automatic speech recognition, etc. Lambda, this will be used for handling the business logic, etc. DynamoDB will be the primary database as a managed NoSQL database. Cognito for user authentication. S3 for storing the static files. The standard, solution, AWS solution, right? A simple standard solution. CloudWatch for monitoring, logging. Elastic Beanstalk for hosting and managing backend. Connect will be used for integrating chatbot into a call center if we want to set that up as well. That is something that can be explored. IAM for the identity and access management, etc. Right? So very simplistic solution, very simple chatbot. There's not much complexity. I'll quickly show you the code as well, right? It's so simple. You can set it up today if you want. You can set up your own chatbot, just get a API and set it up. Have any of you tried building your own solution with APIs, OpenAI or any of them? Nice. We have at least, I think, 10, 12 people who have done it. So others, I would also recommend, please look into doing that. So here there's some providers and provider-based, setup here. There's a little bit of logic about conversation history, storing that, because LLMs are by default not as good at memory, right? They keep forgetting context, etc. So you have to engineer additional stuff so that it can keep context of the conversation, all of that. So we have some logic about that. This is the whole thing, right? This is the base prompt. Here we are just defining what you are. We are telling the LLM what it is, what it's supposed to interact on, how it's supposed to help, and nothing more, right? It's a standard base prompt basically. And then there's API to interact with the agent and send those calls to the API as well, right? OpenAI or whichever API we're using. That's all it is. And we deploy it and set it up, and we have this. I think we just used a EC2 server, nothing much complex right now. On AWS, you have a lot more services. You can utilize Bedrock, SageMaker, etc. But we just deployed this in a very simple way right now. So that's an example, and I recommend you all to also explore creating something of your own. AI agents, again, like this is the big thing, right? The current market trend is about this, right? So there's a lot happening in the AI agent space. There's a lot of companies that are working on how can we build AI agents for use cases across the entire segment, for enterprises, for operations, for everything. So I just came across an AI agent yesterday or day before, which is a product of like production engineer. So you give it access to your cloud and it will detect and find out what are the issues and alerts, etc., incidents, etc., and give you an immediate recommendation of like what is the root cause, what is the fix, all of that, right? So just speed up your efficiency in that way to make sure your systems are live and healthy and running, and you can manage incidents quickly, right? Even when the humans are asleep, it can keep working. So that's one thing I came across. There's a lot of such effort going on across the space. OpenAI just launched Operator, which is basically the OpenAI LLM on top of which it has access to browsing, right? So you can get it to go through browsers, search, click on things, do actions basically, right? So this just recently last week launched. So that's something else as well. Learning resources, few simple ones. Cloudflare has a few good guides on AI and all the topic we have talked about, all the details, etc. They have a lot of good guides on that. So there's the actual articles, etc. Then if you go to the glossary, you will find more and more specific, like what is a vector database, all of that. This is a good introduction to everything that's going on. Then there is 3 Blue 1 Brown's neural networks playlist, one of the best video resources you can go through. There's a lot of resources. I'm just filtering it down for you. 3 Blue 1 Brown is one of the good resources, which he explains it in a very intuitive way and visualizes it really, really well. So he has good videos you can go through for neural network, for backpropagation, for how does a large language model work, what is a transformer, how does it work. He will visualize it for you and it will make sense. You will get it. How does this work, right? Fundamentally, because it's not magic, right? There is actual logic, simple logic behind it. So going through that will make a lot of sense. So this playlist is a good one. He has other playlists as well. There's a GitHub resource I came through, which was quite good, AI Crash Course. This basically first starts with giving you all the research papers, right? Like the transformer paper. What are the big milestones of research papers that have come out that have been pivotal for this entire ecosystem? Then there's planning, reasoning related stuff. There's specific applications built in AI space. Then there's benchmarks like the SWE bench, which tests all the LLM models on coding tasks, right? And sees how well it's able to perform. The best model is still at a level of 50%, I think, compared to a competent developer who might be able to do the same things. So, but they're slowly getting there, right? They're improving month by month, year by year. So these benchmarks give an indication of where we are compared to the, these foundational models. There's a reasoning benchmark, different types of benchmarks like that. There's video lectures. There's 3 Blue 1 Brown mentioned here as well. There's other lectures you can go through, helpful websites and other resources. This is one. Then there's Fast AI course. These courses are a bit dated at this point, but they are still extremely helpful. There's a couple of courses, I think. These are designed for developers actually. So it will teach you about neural nets and deep learning from a developer point of view, helping you understand how to build, how to work with this, how to utilize it, all of that. So good resources here. And there is the CS50 AI course, which is also a good introduction to AI course that you can go through. It will take you through some of the concepts, optimization, learning, neural networks, all of that. And there might be even some challenges that it will give you to solve as well. And finally, of course, nothing is better than building. Learn by building. Get your API keys, build something. So yeah, that's about it. And you can find me on social media. Go to any platform /DattaKapil, that's me. So LinkedIn /DattaKapil, Twitter x.com/DattaKapil, that's me. I have a website, dattakapil.com. You can check it out as well. But yeah, that's about it. Thank you.